morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are listening to the iTunes playlist. We have no idea what's going on. This is something. That's the name of the tune. And of course, this is something because we're doing a little bit of HL mathematics, although this is an insult to the lowest of mathematics, this first problem. This is the solution video to Exam Jam 1 for you HL fans out there. This is unbelievably insulting, so let's get to it. The marks obtained by a group of students in a class test are shown below. Marks and the frequency of the marks. Find the value of K if the mean is 6.5. Are you kidding me? So let's see if we remember how to find the mean. I'm going to do 5 times 6 plus 6 times K plus 7 times 3 plus 8 times 1 plus 9 times 2 plus 10 times 1 divided by the total, and that's going to be 6312, that's 13 plus K, and we are told by all that is IB that that is equal to 6.5. We are thanking everybody that we can that this is our first problem. It's like, here's 4 points. So we do all this, 30 plus 21 plus 8 plus 18 plus 10. In my mind, that is going to be 87. So 87 plus 6K must be equal to 6.5 times 13, which is 84.5, plus 6.5 times K, which is 6.5K. Boom, boom, boom. I get what? 0. No, I don't get 0. I get 2.5 is equal to 0.5K. Therefore, K equals 5. If you weren't able to do that, just go ahead and drop out of school right now. I don't want to know about it. All right. Next up, some probability. A is easy. B is just a tiny little thing you have to recognize, but it should come to you almost immediately. All right, we got this Wonder Woman Emily. She's walking to school every day, and the length of time this takes can be modeled by a normal distribution. That's amazing, with a mean of 11 minutes and a standard deviation of 3. She is late if it takes her more than 15 minutes. She's also a slacker. By the way, a little bit of trivia here. Mr. Becker's mother's name is Emily. Some useless knowledge there for you. Find the probability she is late next Monday. Well, this is a normal distribution, so we could write that the random variable x is distributed as a normal distribution with a mean of 11 and a variance of 3 squared, which means the standard deviation is 3. And we need to find the probability that the random variable x is greater than 15. And so we go to our handy dandy awesome Inspire. I'm always inspired. Oh, I didn't want you to see all that. Let's get, just so we know how to get to it. So menu, probability, distributions. We're going to do a normal cumulative. It's cumulative because anything greater than 15 is considered late. If we were finding the probability that she is exactly 15 minutes late, that would be normal PDF. But this is normal CDF. Our lower bound is 15. Our upper bound for a normal distribution, our upper bound is going to be positive infinity, which we represent with 9E999, which is 9 times 10th to the 999th power. Our mean is 11. Our standard deviation is 3. And there we go. Nice! All right, so let's slap that on our working area. And then we shall write our answer correct to 3 significant figures. Get that out of the way. So that is going to be approximately 0.0912. Boys and girls, that is to 3 sig figs because that 0 is not significant. If you're ever confused about significant figures, write the number in scientific notation. 0.912 written in scientific notation is 9.12 times 10 to the negative 2. And then whatever 3 digits you have here must be included in your answer. I have to have the 9, the 1, and the 2. And in order to have the 9, the 1, and the 2, that 0 is necessary. So that's how I think about it if I ever get confused, which is never. Okay, B. Find the probability she is late at least once during the next week, Monday to Friday. And here's the tiny little twist. This is not a normal distribution. This is a binomial distribution because poor Emily, she is either late or she is not late. Let me say that again. She is late or she is not late. There are only 2 possibilities. 2 possibilities, success or failure. That, my friends, is a binomial distribution. So we're going to say the random variable x is distributed as a binomial distribution with 5 trials and a probability of success of 0.0912, and we are finding the probability that the random variable x is anywhere from 1 less than or equal to x less than or equal to 5, and that is going to be equal to let's do some monkey work, shall we? Menu, probability, distribution. Binom is down low, 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 and it's going to be CDF, not PDF, because it's from 1 to 5. It's not exactly 1 time or exactly 2 times. 1 or more times, so that is cumulative. Number of trials is 5. Probability of success is 0.0912. The lower bound is 1. The upper bound is 5. Boom, chugga-lugga-lugga, and we have our answer. Let's copy that, and let's paste it, and there she blows. That is equal to 0.380. So there you have it. Hope you enjoyed it. I had a great time. Let's see what happened in here on our DJ Jazzy Jeff thingy. We are still jamming. Hope you enjoyed it. B-Dog is out.